Hello, my name is Preston Tong, and I'll be covering Unit 3.7 Solutions and Mixtures. So first, go through the two different types of mixtures. First one is heterogeneous mixtures, the second is homogeneous. Heterogeneous means the different sections that are visible to the naked eye. So if you look at this salad, you'll see the different ingredients, like bacon, eggs, avocado. You can see each individual ingredient. However, for a homogeneous mixture, this is more commonly known as a solution, and it has a uniform composition throughout. Basically, what that means is that you'll have two different things that you'll mix together, and after you mix it, then it will look like only one thing. So for example, you take two things here, sugar and water, you mix it together, and it'll only look like water. You won't be able to see any of the sugar particles because it will be dissolved. So that would be considered a homogeneous mixture. Next is molarity. Molarity is the primary unit of solution concentration in chemistry. And here is the formula to find molarity, which is moles of solute over the liters of solution. So let's do this practice problem with the formula. A student produces a solution by adding 0.711 grams of tin 2 chloride to enough distilled water to make 75 milliliters of solution. Calculate the molarity of the solution. So here we're looking for molarity. And how do we find molarity? Well, we use moles of solute over liters of solution. So first we need to find moles. Now here we are given the grams of tin 2 chloride. So all we need to do is find the molar mass of tin 2 chloride, and then we'll be able to do our molar conversion. So 0.711 grams of SN, which is tin, chloride, which is the chloride, times 1 mole over 189.62 grams. And then the 189.62 grams is the molar mass of the tin, the tin 2 chloride. So we cancel the grams out, and we get 0.711 divided by 189.62, and we get 0.0035 moles. And then, since we have the moles of the solute, we can find the denominator of this equation, which is the liters. Now we're given the 75 milliliters, but we need to convert that to liters, and we do that by dividing by 1,000. So we have 0.075 liters, and then once we divide them with each other, we get 0.05 molarity of the tin 2 chloride. Next, let's tweak the equation a little bit. Let's try this problem. A small beaker contains 50 milliliters of 0.25 molarity NaOH solution. If this solution is allowed to dry, how many grams of NaOH can be retrieved? Well, what we can do is we can convert to moles first, because we're given the volume, the milliliters, and we're given the molarity. So what we're missing is the moles, and we could easily find that. So first, let's change the liters, or let's change it to liters times moles, and that will help us find, or liters times molarity, and that will help us find the moles. So 0.05 liters of NaOH times 0.25 moles over 1 liter. Now, that's just the molarity, okay? Because there's 0.25 moles per 1 liter. And you just multiply those together and you'll get your moles, because the liters will cancel out. 0.0125 moles. And now all we have to do is do our molar conversions into grams. So 0.0125 moles of NaOH times the 40 grams, and the 40 grams is just the molar mass over 1 mole, equals 0.5 grams of NaOH. Okay? And next is this slightly different equation, which is our molarity times volume equal to our molarity times volume. Now, that might be a little bit hard to understand, but let's try this practice problem and I think you'll get it. So, a chemist needs to produce 500 milliliters of 0.25 molarity HCl solution. How many milliliters of concentrated 12 moles HCl solution should be used to create the desired solution? So, what we have to find how many milliliters are in 12 molarity of HCl. Well, first we're given a first scenario, 500 milliliters of 0.25 molarity. So that we can put into molarity and volume. So our molarity will be 0.25 molarity times 500 milliliters. Now for this problem, we don't have to turn milliliters into liters. You could just leave it as milliliters. And then we equal that to 12 molarity HCl times x, and x will be our volume. So once we solve for x, we get 10.4 milliliters. And this is kind of the same as, think about it as cross multiplication, because it's kind of the same. Okay, thank you for listening. Now, these are my extra resources. This is Unit 3, Topic 7 by Jeremy Krug, and Unit 3, Topic 7 by Abigail Giordano. Thank you.